Yeah, thanks for the introduction, of course. Yeah, we are going to show you today what we as Telecom do when we have a lot of data with different shapes and so on, and how we can leverage them to be usable within an LLM bot. And whenever you're having a topic of LLM, oftenly there is a vector DB we have to fill with a lot of information and knowledge before we can really start. And what we do in Telecom is we have a lot of different data sources. We have different shapes, even videos, MP3 data, PDFs, PowerPoints, and so on. And of course, we would like that the LLM bot is aware of all this information. And of course, there are a whole framework world around how we can retrieve data. But for some reasons, we also, I come up later, we built our own framework for that. In general, you can think about, in the end, we have a vector database we want to fill with information. And on this side, we have then different data sources we want to query. For example, web scraping. For example, connecting to a database. For example, an API or other data sources you can think about, even files or other stuff. And then sometimes we have to reshape them, throwing them into a GPT and summarize it, changing the shapes from XML to JSON, split them up, changing the shapes, and yeah, these are important stuff. Then often embedding models and having particular requirement for shapes, for example, the token length and so on. So splitting is an important part. Then embedding is quite expensive because it's taking a while, oftenly tokens costs, and in the end we want the result into a vector database. So one point, we built our own knowledge framework and not leveraged Haystack, Llama Index, LangChain, or you name it frameworks, is that one point is we want a capability to automate our data frequently, and we can schedule them, that it is cloud native, and that we have these multi-channel and multi-tenancy problems. And one main part is also that we don't want to redo stuff we don't need to redo. Because if you have a lot of data, you'd only, for example, if an API changed its data, we only want to redo partially the stuff and not all the things. So what we did is, for example, let's have a look at one of our tenants. This is Austria, where they have, of course, a website, but you can also think about APIs and databases. And you see here are different steps. In between, we say, okay, let's build a markdown, a common data contract, then shape that into the embedding. And then we have the embedded stuff going to the quadrant database or a vector database. Then, if you have a look into Germany, you will find a lot of stuff again. For example, the embedding step and the quadrant step, we can reuse that completely, but we're consuming a lot of other data sources. But still, we have the common contract of the markdown, and then we say, okay, the embedding. So what you see here is we can leverage across NatCos, across channels, the same structures, the same contracts, the same data shapes, by just reusing them across the channels. So what we built is we can deploy that in Kubernetes, and then we can run that. We can run that frequently. We can say that let's run it once a week. If the tenant said, okay, we want to have it, don't talk about data which is older than, or which has to be fresh, and then you can then say, okay, once a week on every Monday, for example, at night, and then you will have such a thing that it starts here at 5, for example, and then it starts to do the jobs, the different steps. So, for example, some legacy steps, then some newsroom, and you have the data points here, and you see some of them are quite fast, so the next step can start directly after the other one. Then you see there's a huge step in between, a huge time in between, and you also can find which of them it is. You see the embedding step, for example, takes a while, so it's quite expensive. So here's one of the main motivations. We would like to redo only when we have to redo, because embeddings are taking a lot of computational time, taking a lot of embedding time. Even it could be an external vendor who wants to pay money for embeddings. So we only want to do that when you really need to do that. So what we have is a caching mechanism between the steps. So the next step is only executed when the data really changed. Yeah. Now I would like to hand over to Max. He will go into the details of the architecture, the code, and the structures.
Yeah, thanks, Thomas. So, as Thomas already described in quite an abstract way, we want to make it easy for anyone to ingest data. So we chose Python as our language of implementation because it's common across data scientists and it's quite easy to get started with, even for people that are not familiar with programming. We try to abstract away most of the concepts or all of the concepts that are integral to our use cases. So for example, caching. Anybody who creates a step or a source does not need to know about caching. He does not need to know what steps follow. He just needs to know, okay, what do I get as an input? For example, if you're just consuming an API, there is no input. You just need access to the internet. He needs to know, okay, what kind of data format do I provide or give out to the next step? Could be, for example, something like a JSON struct or Markdown, as Thomas already mentioned. Then there is this settings as part of the knowledge step, where one can define environment variables, for example, token secrets, and so on. And this together creates the step where which anyone could write. And the main implementation is in the run method, which is already shown here as a Python signature with typing enforced. As sort of the more important types, we have data models, or often also referred to as data contracts. These are, as I said, for example, a JSON struct with defined fields. Yeah. This is, for example, the specific implementation of the embedding step. So it takes as an input a list of Markdown data or Markdown data contracts, and it gives back embeddings or embedded data contracts. And here you can see the struct definitions as we created them. Of course, these can be changed on the fly. Now let's get to the actual coding part. At the top, we have two classes defined. One is an internally used JSON, in this case, and the other one are the settings that needs to be set for this step to run. So for example here, the URL could be changed without another code deployment. Then there's the class. So the top line says it's a typed step or a knowledge step, which takes in the result from HR web scraper. Which takes the settings HR web scraper settings, so defined right above, has no input, and gives out Markdown data contracts. This then allows the IDE to autocomplete this run method, where again, the input is none, the output is the list of Markdown data contracts, and basically anyone who knows some Python then knows what to do, can create something, and this step then can run. We also took care that the return types, or this typing is enforced. So if you return anything but a list of Markdown data contracts, your IDE will complain to you that you're not upholding the contract and the step is invalid. Yeah, that's basically it for this exemplary implementation, or all of our talks. Are there any questions?
Do you have an example how it looks like, how you chain the steps to a pipeline? Could example here? Yeah.
Not prepared yet, but basically you take the class name, and then there's the right shift operator. So for example, for bit operations, we overloaded that. So you could say HR FAQ scraper, less than, and then the next step. That's basically the chain. And of course you can chain arbitrarily, so many inputs to one to many, everything you want to do.
Like ODSL basically to chain steps.
Yep, but we stick to the Python principles, so it's easy to follow.
The only thing we enforce is that the contract fits together. So if you're putting random steps, of course they will not fit, and during the generate, so the first part in our execution, for example in our Docker deployment, will be checking whether the steps fit together or not, and will raise if they do not fit.
This is quite interesting and important, because yesterday I had a look at Haystack, for example, where you can chain components, and then you need to manually link them together via strings, and there's nothing enforced that the data types of the components match to each other. That's why I think its main advantage of this solution here is it's type safe, and also the way how you pipe link this.
Yes, we leverage the possibilities we're having from Pydantic to introduce the type safety between steps at least, because normally in Python you don't have type safety, but in between them we enforce that. And I guess one of the most important things is also that we can easily just contribute to that. And for example, in Haystack you have this document class, which you're getting from the beginning, and then they just transform them, and in the end you have hopefully the right shapes and the right data still there, but you not really have the full control about the whole documents and the whole pipeline.
One more question? Yes, sorry, because I actually don't know it anymore. So long ago. How do you cache the data? Is it still snapshotting? Is it still the tool from Power or something new?
We abstracted the caching completely away. Currently, we are leveraging still the capabilities from DVC, like in Git LFS and a bit fancier. But you can choose whatever pipelining or backend you would like. You can even think about Apache Airflow. We could exchange that in the near future, for example, to have both backends compatible. But currently, we're using DVC to have the caching mechanisms in place. Yeah.
I also have two questions. One is let's say, what's your experience with chunking the documents to right size it for embeddings? Let's say, I don't know how big or small. You mentioned that, sometimes you have.
Yeah. For that, we have this a separate step, or sometimes as part even of the preparation of the embedding step, that we're saying, okay, we want to make sentence splitting, but in a semantic way. So, for example, Haystack does it just, okay, there is a double enter, this has to be a split here. Next thing, okay, again split. What we try to do is preserve, for example, headlines. If you have a main headline with the highest level, then you start to split the document. In the most frameworks, you will just have in the first split the main headline. But we, for example, preserve that across all the splits, and we try to preserve context information better within this preparation of the embedding step.
So that means it's not just text; it's actually marked up text.
Yes. We are using, as here written, our first common contract is this markdown contract.
I see. And then, but let's say, and are you saying that you try to make it as small as you can, but you always include a lot of metadata, or?
No, we have some rules we have to apply. For example, a token length of 500 tokens, and then we have, of course, some buffer for left and right, and then we try to stick the documents to that shape, even try to summarize them or rephrase them to
But
fit.
it's shorter rather than a book, right? It's rather a couple of.
In the beginning, for example, here it can be a huge document, but before the embedding, we shape them and split them. Yeah.
And then my second question. It always happens. Well, we'll come back. Find another one and then.
Any other questions?
Oh yeah. So, which model or which embedding space or which model do you use?
Of course, we have some sub-teams with more experience in the domain of modeling, and of these models in the embedding or even in the NER models, which are changed quite frequently. Every 3 weeks, you can think about we are trying some new embedding models, so it's not really a.
And that's why you need caching.
Of course, yeah, because we are having a high
The
dynamic.
goal is to put it in a database.
Yeah, because we have a highly changing infrastructure. Also, the parameters of the embedding, token lengths, and so on can change with the embeddings, of course. So the caching mechanism is quite important here, that we don't redo all the stuff. For example, we have in Germany this FAQ step, which is scraping the website. And scraping of a website is not trivial because of this AJAX and JavaScripting and all the stuff happening on websites. And of course, then we would like to avoid that quite oftenly. And yeah.
Okay, but basically you use whichever embedding space is needed as per whichever country and model they...
Yes, for example, we have the concrete implementation here written. The embedding step is just an abstract step that it tries to call an API. And we have this, we leverage the Hugging Face embedding API. So our tools team deploys a new embedding model and just say, please make an ephemeral deployment with that thing. And then we run a new pipeline, pointing to another embedding model. And we're just exchanging this API URL and saying, for example, for cosine, it's important that we're normalized. For L1 norm or so, you don't normalize. So you can just configure that. Run the new pipeline. You don't even have to do a commit, just a kubectl config change.
But let's say, moving from the technical part, which I appreciate, but let's say, do the different countries have different requirements?
Yes, of course. For example, the languages are quite different. So embedding spaces are more trained for example, the Croatian language, or more trained for the German language, because you have even other ASCII signs. So the embedding is quite important for languages, channels, and so on. Yeah.
So it's not specific to the model; it's specific to the language.
Models and language are quite correlated to each other. Yes.